Now let's go to the working fluid function editor. So I will click here. Now I have to add the sunshine hours. I will take sunshine hours from 8 a.m. to 4 p.m. You can also take any, let's say you can take from 6 a.m. to 5 p.m. or 7 a.m. to 5 p.m. according to your location. So first will be 8 p.m. and flow rate will be 0 kg per second. Click OK. Then add 8 a.m. and now my fluid flow rate will be 3.06 kg per hour as I have shown you in my mathematical calculation. Next one, now my simulation will begin from 8 a.m. to 4 p.m. 8 a.m. to 4 p.m. and my working flow rate will be 3.06. Click OK. Now my simulation will end here. Flow rate will be 0 at 4 p.m. it will be ended, and now for 24-hour flow rate will be 0. Click OK and double click on result plotter. So in result plotter, number of left axis variable, in our case it will be 3. Inlet temperature, outlet temperature and ambient temperature. Number of right axis variable will be 0 and left axis maximum, this will show the temperature. So I will simply enter 200 or let's say 250. Click OK. Input parameters, now you see 3 axes. So my first axis will be label it T in. Left axis variable 2 will be T out, and this will be T ambient. Okay. So now connect the respective parameters. Double click on this arrow and here connect dry bulb temperature with ambient temperature. For doing this, click and drag this arrow and click on ambient temperature. These are connected. Similarly, you will connect other parameters of all the components due to the time constraint. I will show you the connected parameters. You will connect according to that in your simulation setup. Now connect total horizontal radiations with the horizontal radiation, total diffuse radiations on the horizontal to the horizontal diffuse, total tilted surface radiation for surface with the incident radiations, and similarly connect the angle of incidence to the incidence angle and slope of surface to the collector slope and click OK. Similarly, these values, average water draw to the inlet fluid rate, click OK. Similarly, these values, outlet fluid temperature from the pump will be the inlet temperature of a parabolic trough collector, and outlet flow rate will be inlet flow rate for the parabolic collector. Click OK, and these weather data. Connect dry bulb temperature with the left axis variable 3 ambient temperature, and this connect outlet fluid temperature to the left axis variable T1. Okay, now this one connect outlet temperature from the parabolic trough collector to the left axis variable T out. Then okay, now all the variables are connected. Now pump parameters, these are the values I typed manually: inlet flow temperature, fluid flow rate, etc. And for Parabolic trough collector values, double click on this. Now you can see number of seals 1, collector area 0.8263 meter square. I have taken this value from a mathematical calculation. Fluid specific heat capacity, collector efficiency factor, overall loss coefficient, wall reflectivity, half acceptance angle. In 90 you can also take 65, 75, 45 according to your calculations. Absorbance of the absorber tube, because in my case the receiver tube and trough are both stainless steel, so I added the absorbance 0.95. Input parameters: inlet temperature 298.15 Kelvin, flow rate 0.00085 kg per second, ambient temperature 283 Kelvin, incident radiation I took 500 watt per meter square. You can this is the average I took. You can take 1200 according to your desire, according to your location, your sunshine hours, and incident radiations in your region. Ground reflectance incidence angle is 31.52. In my case it is Lahore or New Delhi, the latitude of Lahore is 31.52. That's why I took incidence angle 31.52. Similarly, zenith angle, solar azimuthal angle value is given in this table. For simulating this parabolic trough collector solar thermal system, I will go to the settings. If I want to calculate for the January, let's say January 1 to January 2, and in this section you put 1 hour simulation time steps. So this will calculate from 8 am to 4 pm, and now click on run. So you obtain the results of T outlet temperature. The blue line indicates outlet temperature, red line T in, pink line T ambient. Here you can see our simulation is started from 8 am and ends at 4 pm. In this graph we can see that the maximum outlet temperature we obtained at 2 pm, and which is about 120 centigrade. If you click on white background, you can also get this graph in white background. Here this axis is temperature axis in centigrade, value 250. Here are the heat transfer rates, and this is the simulation time. You can also find out the results for the whole January month. For doing that, you will go to the 31st January, click OK, run the simulation again. Now you obtain the results for the whole January month. Similarly, you can also calculate for in summer. Let's say I will calculate for May month. So for May month, go to the setting, May. Let's say I calculate for May 10 to 11, click OK, run the simulation. Now we can see from the graph that we obtained maximum temperature, which is about 167 centigrade, 168 centigrade. Similarly, if I want to calculate for the whole May month, I will go to the settings, and here I will click 31st May, click OK, run the simulation again. Now you can see we obtained the results for the whole May month, and we obtained about it's about 225 centigrade. So these are the outlet temperature results obtained from the parabolic trough collector when working fluid is Therminol VP-1. So you can calculate these results in any month of a year according to your location, your incident solar radiations. You can analyze the graphical data and find out its. Furthermore, we can also find out the results of temperature, outlet temperature from the solar thermal collector during the whole year, starting from January 1 to 31st of December, from sunshine hours from 8 a.m. to 4 p.m. For calculating those results, click on setting, and here you will select January 1 to December 31st, and this in this section you will enter 1. So click OK. Now run the simulation. You can see that you have obtained the outlet temperature results when working fluid is Therminol VP-1, and you have obtained approximately maximum temperature, which is about 237 to 238 centigrade, and these are the simulation time. This simulation is run from 8 a.m. to 4 p.m. considering all the months of a year. The pink graphs show you the ambient temperature, and the blue lines indicates the T out, the temperature rise from the solar parabolic trough collector, and T in is constant. You can also obtain this graph in white background with thick lines, and you can also create a JPG image from this file. So in this way we can calculate the results of the whole year calendar. So if you find this video useful and informative, subscribe my YouTube channel and like the video, so I will bring more informative content related to engineering simulations, solar thermal collectors and energy sector. Thank you for watching my video.